So it's h of h inverse of x. So you take the square root, and in place of the x we put h inverse of x, plus 5, and then minus 5. This is all still inside the radical, and then minus 4 outside. So what I did here is I took h of x, so it's, if you look at it up here, okay, and just follow the pointer, so 1/4, 1/4. X, well, in place of x I put h inverse of x, so it's all of this. This is x, all of this right here. Minus 5, minus 5. And then outside of the radical, minus 4, minus 4. Okay, so now we're going to simplify this. Now, inside the radical, 5 minus 5, I can cancel to get 0. And then 4 times 1/4, so that becomes 1, 4/4. And then I have x plus 4 squared minus 4. Minus 4 is outside. So this here, it's a square root of a square, so then that gets rid of the radical. So then you have x plus 4 minus 4. So that's gone. So that gives me x. So now I do the other direction. H inverse of h of x. Okay, so I'm starting with h inverse, so it's going to be 4 times x. For x, I'm going to put all of this, the whole h of x function, including the minus 4. So it's going to be square root of 1/4 times x minus 5 minus 4 plus 4 squared plus 5. Okay, so follow the pointer again. So I'm starting with h inverse, so I'm starting with this function. Okay, so watch, 4, 4. In place of the x is h of x. So I'm put all of this from the radical all the way to minus 4, all of this is h of x. And then plus 4, squared, squared, plus 5, plus 5. Okay, so now I'm going to simplify. Okay, so 4 minus 4, this part cancels as 0. And then I have, let me write it clean copy here. This is what I have left so far. Squared plus 5. So the square root of a square is just an inside number, the radicand, right? It gets rid of the radical. So 4 times 1/4 x minus 5 plus 5. Okay, so the square root of a square gets rid of the radical. X over 4 over 1/4, or 4 over 4 is 1. And then we have negative 5 plus 5, that's 0. So we're left with x. So again, we got x for that composition, we got x for that composition, so that makes this answer right. Alright, we're going to start by finding the inverse of g of x. We don't have to restrict the domain because a cube root function is 1 to 1, so there's no need to restrict the domain. Okay, so I have changes to y, the g of x to y. And so we're going to subtract 1 from both sides. And then we want to divide by 2. Again, both sides, so that this 2 is gone from the right side, because little by little we want to leave x by itself. Now the cube root on the right side, we've got to get rid of that, so how we do that is by taking both sides, raising them to the 3rd power. Okay? So now I have y minus 1 over 2 cubed equals x minus 2 because the radical's gone. And so now I add 2. And so I have y minus 1 over 2 cubed plus 2 equals x. Switch the x and the y. And then make the y back into into function notation. So g inverse of x equals x minus 1 over 2 cubed plus 2. So this is what the inverse would look like. And then it says to graph both of them on the same graph. So remember, for the cube root function, the reference points are -1, -1, 0, 0, 1, 1, and I'm going to use A2 just to be on the safe side, okay? Now, H in this problem is 2. A is also 2, and K is 1. So that means that the x's are going to be, we're going to add 2 to the x's, so this is going to be x plus 2. And for the y's, we're going to multiply by 2 and add 1, because A and K. So let's go ahead and transform the points. So x plus 2, so -1 plus 2, that's 1. And then for the y, -2 plus 1 is -1. And then 0 plus 2 is 2. And then 2 times 0 is 0 plus 1 is 1. And then 2 plus 1 is 3. And 2 times 1 is 2 plus 1 is also 3. And then 8 plus 2 is 10. And then 2 times 2 is 4 plus 1 is 5. Okay, so I'm going to go ahead and graph. Okay, so we're going to graph 1, -1, 2, 1, 3, 3, 10, 5. Okay, so this 10, 5 is there just to make sure you graph the curve in the right direction. So you go from the point of inflection, or the inflection point, and you graph out like that, and then same thing, inflection point, and then you go down, and there's your graph. Okay, now I'm going to change colors for this. So this would be the g of x, so always label. So this is g of x, and now we're going to graph g inverse of x. And remember how you switch the points? So instead of 1, -1, we're going to do -1, 1. Instead of 2, 1, we're going to do 1, 2. Instead of 3, 3, well, that's going to stay 3, 3. And 10, 5 is actually 5, 10. So 5, it's not going to fit, but it's going to be over here somewhere. 5, 10. It's going to be right up here. Okay? So you could go from the inflection point up like this, from the inflection point down like that. Okay, so the blue graph is your g inverse of x. And that's a cube function. You can see that right here. It's a cubic function right here. Okay, and that's why it's going in this direction, because it's a cubic function. Alright, so for number 11, you have a cube root function, and they want you to use reference points to transform, and we're going to graph it, state the domain and range, and describe end behaviors. Okay, so b is 1 and h is 0, so the x is not going to change at all. On the other hand, for y, a is -2/3 and k is -3. So that means we're going to multiply the y's by -2/3 and then subtract 3. But the x's are not going to change. Okay, so the x's stay So no changes. Okay, so negative 2/3 times negative 1 is positive 2/3. So that means when you subtract 3 from that, you get negative 2 1/3. 0 times negative 2/3 is 0, minus 3 is negative 3. 1 times negative 2/3 is negative 2/3, minus 3 is negative 3 2/3. And then 8 times negative 2/3 is negative 16/3. So negative 16/3 minus 3, well, I'm going to change it to a common denominator of 3, so it's going to be 9/3. So that's negative 25/3. So that's actually going to be what? Negative 8 1/3. Okay, so these are the transformed points. It says graph it neatly and label, so we're going to graph it next. Okay, so we're going to plot the points negative 1, negative 2 1/3, so negative 1, negative 2 1/3 about here. 0, negative 3, and 1, negative 3 2/3. Okay, and 8, negative 8 1/3, so about here. Okay, so there's a reflection over the x-axis on this one because A is negative, so it goes like that, and then like that. Okay, so the inflection point is 0, negative 3. This point, oops, sorry. This point right here, that's the inflection point. Okay, what else? State the domain and range using the notation. So for number 11, they want you to use set notation. So to say that it's all reals, because the domain and the range is all reals for any cube root function, and any cube function for that matter. So for the domain, you're going to say all x such that x like this. Oops, infinity. And then you put like the little braces that I can never draw, like that. And for the range, it's the same thing, but y. You put y such that y is between negative infinity and infinity, and then those little braces. And then describe the end behavior. We say as x goes to negative infinity, f of x goes to positive infinity, because as you go to the left, the graph is going up. As x goes to infinity, f of x goes to negative infinity. As you go to the right, the graph is going down, y is going down.